Well, hello, good day for all my Algebra 3 students. Hopefully you're doing well and having a good week so far, had a good weekend. But today we're going to be with this lesson. We're going to talk about this last lesson, which is 5.3, the arithmetic and geometric sequence applications. So some real stuff that deal with these sequences. And so our goals right here are to determine if the sequence are arithmetic or geometric. Remember, for arithmetic, you're going to be adding. And sometimes you're going to be adding a negative number, sometimes you're going to be adding a positive number. And then geometric is all about multiplying. So multiplying, sometimes you're going to be multiplying times a real number, sometimes bigger than one, sometimes smaller than one. It could be a decimal, and that's okay, as long as we know the difference between the two. So anyway, the goals are to find your arithmetic or a geometric sequence to solve problems. So that's what we're going to be doing today. So what I've done, I've written a few things down already just to make this lesson a little bit quicker, but we'll be talking about these one by one for all three of these examples. I'm going to get my goofy face out of the way. Okay, so in this sequence is the arithmetic or geometric and explaining this, but first we got to see what the context is. It says a chain email is set up on the internet, so we got a chain, and the first person sent it to email to 5 people. Okay, so you were one person, we send it to 5 people. Okay, so we got 1, 1, 1, 1, 1. So there's 5 people right there. And then that's for round 1. And each of these 5 people is asked to send it to 5 more people. So this is round 1. In round 2, they send it to 5 people. They send it to 5 people. They send it to 5 people. They send it to 5, and they send it to 5, which is a total of 25. And these people, there's 5 people right there, and there's 1. So if you can see the pattern that's been going on, and it says and so on. So it goes on forever. So my sequence, it looks like this. So 1, 5, 25, comma, dot, dot, dot. And so hopefully you can see what kind of pattern is going on here. So from 1 to 5, it looks like we would have to multiply 5 or add 4. So, and then until we get to the next term, you know if you add 4, it's not going to give you 25. So the only other option is that we got to multiply times 5 for both of these. Geometric, because you're multiplying by 5 by each term. Okay, so that's how we go for that one. And that's how we know to get to the next term, multiplying. And so the next one says, how many emails will be sent in round 10? So in round 10, if we know round 1 is like the second level, round 2 is the third level. So what we're actually looking for is the 11th term, which is going to be your n in this situation. This is to write an explicit formula for the sequence and use it to solve the problem. So for one thing you got to know is that we're looking for the 11th term for round 10. We got to know what the first term, which is the first one, and then the n that we're going to be searching for is 11. So whenever we see this in the formula, we're going to be using n to be 11. Because we're going to be multiplying each term by 5, we know we're going to be dealing with a ratio and not a difference. So the r is going to be 5 because that's what we have going on here. So the explicit is this formula. So a sub n is equal to a sub 1 times the ratio to the power of n minus 1. So if we just fill in these values, so we're looking for, once again, the 11th term is equal to the a sub 1, which we found earlier to be 1, times the ratio, which is 5, to the n. Now the n we're looking for is the 11th term, so 11 minus 1. So if I put this in my calculator, 1 times 5 to the 10th power, which is a really big number. Now if I plug that in my calculator, I'm going to get a number in my calculator, which I already found earlier, to be 9765625. And so to figure out what that is, I just go 3 places over, 9,765,625 emails. That's what it's going to be just on the 10th round, which is kind of like my 11th term. So my 10th round is going to be that. That's a lot. And so if you know about network marketing and stuff like that, that's a lot of emails, and you've got a really good chance of getting those. Okay, the second question here is like, what is the total number of emails? So total is that we're going to be doing something called a summation. And since we have a finite, and since we talk about only 10, we're going to do a partial sum. It says to use an explicit formula, and remember explicit has we're trying to find a particular term to solve the problem. Okay, so we're looking for this 11th basically term and adding them all together, where we know our first term is going to be a 1, the n is going to be 11, and we found out earlier that our ratio is going to be 5. So now we have all those values. Now we're going to put it in the explicit formula, which looks like this. S sub n is equal to a sub 1 times 1 minus the ratio to the power of n, all divided by 1 minus the ratio. Now this can only work, once again, this can work all the time because it's a finite series. So the n sub n, S sub 11, is equal to the first term, which is 1, times 1 minus the ratio, which is 5, to the power of n, which is 11. That's going to give you a ginormous number, and 1 minus 5. Okay, so if I plug this in the calculator, the summation for the 11th term is 1 times 1 minus 5 to the 11th power. So this gives you a negative 488,28124. A ginormous number divided by 1 minus 5 is negative 4. So if I put this all in my calculator, the sum of those 11 terms, including you getting that email, is going to be a total of 1220731 emails. And doing the comma, so 12,207,031 emails. And that's for the total number of emails in this partial sum. I can't go to infinity. The main reason because that number right there is a partial, is bigger than 1. So we got to do the partial sum, not the infinity sum. Okay, going to the next level, on the next step here. So hopefully I can make this under around 10, 11 minutes. And for my final one, and so we have a stone that's being thrown across, it skips across the surface. Like, hopefully you've done this before, it's pretty fun. So the first skip is 5, the second is 3.5, and the third is 2.5, and so on. So dot, dot, dot. So this is going to be my a sub 1. This is going to be my a sub 2. This is going to be my a sub 3. So we're going to figure out if it's arithmetic or geometric. And to do that, I first need to write down my terms, which is 5. We got 3.5. We got 2.45, and dot, dot, dot. And so to get from 5 to 3.5, you can do one of two things. Either divide or we got multiply times the ratio or subtract. So from 5 to 3.5, I know I'll subtract 1.5, and I'll subtract 1.5 from 3.5. I do not get a 2.45. I actually should get a 2. And since I can figure that out, I want to see what my ratio would be. So to find out what that ratio is, I take the second term and divide it by the one before that. So 3.5 divided by 5 will give you a 0.7. And I want to see if that's true for the other one. If I do 2.45 divided by 3.5, that will also give you a 0.7. So yes, that's going to be my common ratio. So that's going to be my R, which is 0.7. I may need to circle that just because I know I'm going to be going back. And it is geometric. Geometric because you're going to be multiplying by 0.7 for each term. Okay, so that's where we go for that one. So we answered that question pretty easily. So now here's the question for part B. If it keeps on skipping and doesn't sink in the meantime, how far will it eventually travel? So answer to the nearest meter, explicit formula. So explicit in an infinite summation, and this is the thing, it doesn't sink in the meantime. It goes forever. And so to find out what that is, we know our first term is going to be 5, as we said earlier. And the one that we're going to need also is the rate, and the ratio is a 0.7. And if we use this summation for infinity, this value always has to be less than 1. So in other words, the absolute value of R must be less than 1. Okay, it has to be in between 0 and 1. Okay, but it has to be less than 1 for sure, because if it's greater than 1, that infinite summation is going to get forever bigger. So we don't want that. So here's where we got in between that. I already wrote it down. So for the partial or the infinite summation, we use this formula. So that the summation of all the terms put together, we take that a sub 1, which you find to be 5, and 1 minus the rate, which is 0.7, or the ratio. Okay, so if I put that on the calculator, the summation of all that will be 5 divided by 0.3, and that will end up giving you a 16.6 repeating. And so if I kind of round to the nearest meter, as it says so right there, it's going to give you 17 meters. Okay, so there's the real-life applications for the sequence stuff. So hope you guys understand what's going on, and let me know if you ever need some more help on understanding this content. Okay, guys, have a great rest of your day. See you soon.